Hi everyone, and welcome to our video on box and whisker plots. We just finished our lesson on stem and leaf plots. Stem and leaf plots are a way to organize data. Box and whisker plots are also a way to organize data, but they're quite different. So let's take a look at our first page, which really, I'm just going to kind of read to you because it just goes over some basic vocab and just vocab for box and whisker plots. So here's the definition of a box and whisker plot. A box and whisker plot is a graphic way to display the median, the quartiles, and the extremes of a data set on a number line to show the distribution of the data. So that's the official definition. Now, this right here is a picture of a box and whisker plot. So let's go over some of the vocab that's entailed within a box and whisker plot. So you have your smallest value in your data set. Sometimes that's called the minimum. In fact, when we do this on our TI-84 a little bit later, I'm pretty sure the TI-84 calls this the minimum. Okay, and you see here they've got that represented by this sort of vertical line segment. They also have the greatest value up here on the right side. The greatest value in the data set is also sometimes called the maximum. And they have that also marked here as a vertical segment. Now you can see they've got the distance here between the two. The highest to the lowest is called the range. And we already know the range is the highest minus the lowest, or the distance between the two. So they've got that marked. And then they've also got, so they've got this mark, they've got this mark. Now they've got this horizontal line segment, which measures the distance from the smallest value to what they're calling the first quartile. And we'll talk about how you find the first quartile in just a minute. But I just want you to know that the first quartile is sometimes also referred to as the lower quartile, or sometimes you'll see it referred to as Q1, the first quartile. Then you have your median. We already know how to find the median of a set of data. That's the dead center, that's the middle. And then they've got the third quartile here. The third quartile, which they're representing with this vertical segment, is also sometimes known as the upper quartile, or Q3. Well, you might be thinking, where's Q2? Well, the median is sometimes referred to as quartile 2. Okay? And so what is going on with all this? Well, you see the box right here. So quartile 1, the median, and quartile 3 form what we call the box in a box and whisker plot. The whiskers are these guys. Think about whiskers. They stretch out. So the whiskers are simply the distance between the smallest value and the first quartile, and the greatest value and the third quartile. So kind of the way I want you to think about it is this. You have a set of numbers. You have a set of numbers. Let's just say these are your numbers. These little dots are going to represent the numbers. How many do I have here? 1, 2, 3, 4, 5, 6, 7. I'll give a couple more. 8, 9, 10, 11. So the whole idea is you have a set of 11 data right here. 11 numbers, 11 values in your data set. Well, here's your smallest value. That's this guy over here. That's your smallest value. And then here's your biggest value. That's this guy, the greatest value. Your median, let's see, let's count to the middle. We would cross these two out, 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 and here would be your median. Median. That's the dead center. Now, isn't it true that from your smallest value to your median, that's 50% of your data? It's half. And from the median to the highest value, that's also 50% of your data. The median cuts your data in half. So now you've got a 50-50 proposition here. Well, if you find the median between the smallest value and the median, then you are finding, so let me say it this way, and I'll show you this in the example. Here's your median, so we don't want to include him. So say you're going from this guy to the smallest value. If you cross this guy out with this guy out with this guy, that is called your quartile 1 because you just quartered the data. If you take half of half, now you've got 25% and 25%. Same thing. If you quarter half, now what you're doing is finding the middle of the upper half of the data. So now you've got 25% here and 25% here. That's why these values are called quartiles. This would be your quartile 3. So just trying to show you how the language got created. The word quartile didn't just come out of thin air. It goes with quartering a whole set of data. Quartering, 25%. Okay, so let's go here to range. We already know the definition of range. It's the greatest value minus the smallest value. Here's something new we haven't talked about. Interquartile range. This is a new term for you. Interquartile range is simply the third quartile minus the first quartile. So it's the right side of the box minus the left side of the box. Third minus first, where regular range is greatest minus smallest. Okay, so you have the overall range and then you have the interquartile range. And last but not least, this is just reiterating what I said up here. Each part of a box and whisker plot, each part of the picture represents 25% of your data. Each part, just like I'm writing here. So the first whisker is worth 25%. The distance between the first quartile and the median represents 25%. From the median to the third quartile, 25%. And from the third quartile to the greatest value, 25%. Okay, let's get into actually working with some box and whisker plots. So let's take a look at example 1. It says, below is a list of the scores earned by 17 students on a science test. And I do believe I was kind here, and I've already put them in order from lowest to highest. It says, make a box and whisker plot for the data. Okay, so the first thing I like to do, I like to find my lowest value and my highest value, because those are very easy to plot on my number line. So since my smallest value is 63, I go to 63 on my number line, which will be halfway between 62 and 64.
Mr. Campalupo, please contact the guidance office. Mr. Campalupo, please contact the guidance office.
And I put my vertical segment there. Now I go to the highest value, 95, which is right here between 94 and 96, and I put my vertical segment there. Okay, so that corresponds to these guys right here. Now, the next thing I like to do is find my middle. I like to find my median. So we start to cross things off. So I'm going to cross the 63 with the 95, 67 with 94, 67 with 93, 74 with 92, 74, 91. Keep going carefully until you reach the middle value, and there it is, 87. And I knew there would be a dead center because of our odd number of students taking the test. So we have an odd number of test scores. Okay, so that median, 87, let me find 87 right here between 86 and 88. That gets another vertical line segment. So this guy here, the median, goes with this guy right here. This is going to be inside the box eventually. Now, I have two more items to find, and these are my lower and upper quartiles. So now what I want to do, I've got 50% of my data right here. I want to quarter this. So what I want to do is this. You do not want to re-include the median when you're going to find your lower quartile. You only want to find the middle of the numbers below the median as well as the middle of the numbers above the median. So leave 87 out of it. And what I like to do is double cross. Since these already have crossing out through them, let's double cross them. So the 63 with the 86, the 67 with the 82, the 67 with the 79, and now here we have two numbers in the middle. So I have to average them. So to average two numbers, I add them and divide by 2. So bringing my TI in here, 74 plus 74 divided by 2 is, you guessed it, 74. So the lower quartile, or Q1, is 74. So I will go to 74 right here, and I'll put another vertical line segment. And finally, if I go up top here above the 87 and start double crossing, I'm going to cross 88 with 95, 89 with 94, 90 with 93, and now I have 2 in the middle, 91 and 92, so I'm going to have to find the middle of those. So 91 plus 92 divided by 2 is 183, if you can see that, divided by 2, and 183 divided by 2 as a decimal, 91.5. So Q3 is 91.5. So I will find 91.5. That's about, let's see, 91, just a little bit to the right. Do your best. It's just an estimate here. So now I just have 5 vertical line segments. Well, we know what to do. The inner 3 get connected top to bottom to form the box. The whiskers stretch from quartile 1 to the minimum and from quartile 3 to the maximum. Now, each of these sections is worth 25% of your data. Now, students will often say to me, and you may be thinking it yourself, I don't get it. 25%, like, shouldn't they be the same size sections? Like, how can this little tiny section be worth 25%? And then this longer section is also worth 25%. Well, that's a great question. Here's the answer to it. If you look at the top half of your data, like, let's look, I'm going to go over this in pink because I've written on this so many times, but if you look at this, a lot of scores right here are concentrated in the high 80s to the mid 90s. So you have a lot of scores that are, you know, in a small amount of space, so to say, or there's not a wide range here. But if you look even closer at this part, the upper part here that goes with this percent of the data, the distance between your third quartile and your maximum, there is little to no variance in those scores. They're very close together, so you're going to just have a small whisker. Whereas if you look at the data here in the first part of our set, we're going everywhere from 63 to 74. That's a 10-point spread. So that is going to look more stretched out, even though the same amount of scores are in there. See, 1, 2, 3, 4 scores. 1, 2, 3, 4 scores. So 4 scores in each set, but stretched out, less stretched out. Same amount of data, same percentage, a little bit more stretched out versus less stretched out. So hopefully that makes sense. It's hard to do on a video when I can't see you and see how you're reacting to this, but That's the reasoning behind that. Okay, let's go to example 2. Example 2 says, given the box and whisker plot below, so they've already drawn it for us, answer the questions that follow. Okay, so what is the largest number in the data set? Well, I hope you're looking over here. And that hooks up with 28. What is the median of the data set? Well, I hope you're looking right here. That's 22. What percent of the data lies between 18 and 26? 18 to 26, well, if this is 25% of my data, and this is 25% of my data, and this is 25%, and this is 25%, then I would say that between 18 and 26, we have 50%, 25 plus 25. Okay, what percent of the data lies between 16 and 18? 16 to 18, can you see? 25%. What is the interquartile range of the data? Well, remember, interquartile range is Q3 minus Q1. Upper quartile minus lower quartile. So let's take a 26 minus an 18, and that's 8. And last but not least, what is the value of the upper quartile? That's this guy. That's 26. So reading box and whisker plots is fairly easy, I think. Let's go on to our final page here. Example 3. The following are the ages of 12 math teachers in a school district. This is how old the math teachers are. Use your TI-84 to create the 5-number summary for this data. And by 5-number summary, I mean the minimum, the lower quartile, the median, the upper quartile, the maximum. You can do all of this on the TI-84. So that's what I'm going to teach you right now. So let me make sure this has good light. I want to be able to see my data. So turn your calculator on, and we are going to press a key called STAT. See it right here? Oh, you can hardly see here. STAT is right here where my finger is. Alpha, the green key, go 2 to the right, and you will see STAT. Go ahead and press it. And since we're about to put data in, we're going to edit. So edit is already highlighted as number 1, so you can just press enter. And basically, these lists are going to come up. Now you can see I've already done something here. So the first thing I want to do is get rid of all my old stuff. So I want to arrow up to highlight L1. And I repeat, do not press the delete key. That'll delete the list, including the L1. I don't want to do that. I just want to delete these numbers. So actually what you press is the clear button. So hit clear and then enter. And boom, it's gone. And I start fresh. Now I only have one list of numbers, so I'm going to put those right down L1. So we won't be using any of these other lists, just L1. So here I go. I'm going to press in 31, and then I press enter to store it. 33, enter. 36, enter. 42, 45, 47, 53, 54, 55, another 55, 58, and our oldest math teacher, 59 years old. Okay, so now you have all your list in. Now we want to calculate some things. So we're going to press down the stat button again, next to 2 away from alpha, hit it again. But we don't want to edit anymore. We've already edited. We've put the data in. We want to calculate something now. So take your right arrow, highlight calculate, and it's also number 1 we want, 1 variable stats. So hit enter because it's already highlighted. And here is just a cross check. Is your list, are all your numbers in L1? Yes. So just arrow down here to calculate and hit enter. And you're going to get a bunch of numbers coming up on the screen. Okay. Well, I will tell you, even though we don't need it for this problem, this little X here with the horizontal segment over it, that's your mean. The calculator will actually do your mean for you. Now, we don't need that for this lesson, but that is your mean. This right here, this sigma with the X, we don't need this, we don't need this, we don't need any of this. I want you to keep arrowing down until this n equals 12 is at the top of your screen. Now, what the n equals 12 means is that you inputted 12 items. That is true. We had 12 math teachers and their ages. I'd like you to verify that because sometimes if you do a typo when you're doing data entry, if this like would say 13, then you would know, uh-oh, I didn't enter this incorrectly. So always cross-check this number with the numbers that you put in. The rest of this is your 5-number summary. Lowest minimum value is 31. That is our youngest math teacher. So put 31 for your minimum. Look down here at the maximum, 59. Wasn't our oldest teacher 59? So maximum 59. The median, 50. Okay, so let's put a 50 for our median. And if you did the math, if you cross, you're going to get 50. Your lower quartile, look what it says, Q1, 39. And upper, 55. Beautiful. Now, if we had done all of this by hand, it would have looked something like this. We would have crossed the 31 with the 59, 33, 58, and so on. Now, we probably will end up with 2 in the middle. We sure do, because we have an even number of data. If we average a 47 plus 53 divided by 2, see how we get 50? That's the way you do it by hand. The calculator did it too. Now, what's cool about this, though, I need to bring this up for if you're ever doing this by hand. Do you see how the median is right here, 50? That's the median. So when you go to find your lower quartile, you never include the median. But since the median lies between these guys, count the 47 and count the 53. Because neither of those numbers is the median. So they get included when you're double crossing. So here we go. The 31 crosses with the 47, the 33 with the 45, and now you're down to 2 in the middle again. So you would average the 36 and the 42 to get 39. That's how they're getting 39. Same thing up here. You would cross the 53 with the 59, the 54 with the 58. You're left with 2. If you average 55 with 55, it is, bing, 55. Okay. They also want the inner quartile range. Now, the calculator doesn't display that. We just have to find it, but we know how to do that. It's Q3 minus Q1. So it's our upper 55 minus lower 39, and 55 minus 39 is 16. Final answer there. Okay, last problem, example 4. We're going to compare 2 box and whisker plots. So let's get into it. It says the box and whisker plots below show the test scores of 2 different periods. So we've got first period's box and whisker here, second period below. The students in both periods took the same test. Okay, and these are how their test scores. This is a graphical display of their test scores. So let's get into these questions. Which period had the highest test score? Well, we're comparing this dot to this dot. So I would say this dot is higher at 100. So period 1, first period, had the highest test score recorded. Which period had the smaller range? A smaller range. Well, here's your range for period 1, and here's your range for period 2. So which distance is smaller? Second period. It's more squished in. So this is second period. You could also do the actual calculation. If you take 100, is that even at 100? Boy, that's a little shy there. I take that back. First period still had the highest score, but it wasn't 100. It might have been like, I don't know, maybe a 98. But if you take a 98 minus a 60 versus a 95 minus a 70, the 95 minus 70 is smaller. All right, letter C. Which period had a larger interquartile range? Okay, well, larger interquartile range. So what's bigger? This distance or this distance? To me, this distance looks bigger. So, yeah, because we're taking practically 90 minus 80 versus 75. So I definitely think first period has the larger interquartile range. First period. And last but not least, which period had a larger median? So now you're comparing the medians. And you can see second period had the larger median. So lots of different examples, from reading box and whisker plots to using the TI-84 to drawing your own box and whisker plot to knowing the breakdown of the percentages. There's a lot going on here. Hopefully it all made sense. We're obviously going to practice this, but thanks for watching and for understanding box and whisker plots.